Hey everyone, today we are here for discussing top 10 Elasticsearch mistakes. Elasticsearch is one of the easiest database to start with and one of the easiest to quickly break. The training is built on an audit of over 3000 real clusters and it walks through 10 mistakes that show up again and again. What they are, why they hurt, and exactly how to fix them. Whether you are studying for these for classes, handling a production cluster, or preparing for an interview, this is a short list that matters. Here is the thing about Elasticsearch. It's simple to set up, but the simplicity hides this. A cluster that feels perfectly fine for a 3 node 10 setup can slow down over 10 times over the moment when real traffic and real data show up. And these problems don't announce themselves. Most teams don't know they have one until something actually breaks. This isn't guesswork. Every mistake is a day comes from analyzing over 3000 real clusters and the same 10 failures pattern keeps showing up for small startup to large enterprises. Mistake number one, oversharding. This is when a team splits an index into far more shards than it needs. Think 50 shards for a 5 gigabytes index. One real team ran 4500 shards across just 5 servers. The cluster started following circuit breaks, errors, and queries timeout until it was effectively unusable. Here's why every shard is its own mini search engine with its own memory and CPU overhead. More shard doesn't mean more speed, it means more coordination work. Think of it like splitting a book into thousands of tiny pages instead of 20 chapters. Finding one fact now means flipping through every slide, every single page. The fix. The fix is straightforward. Keep each shard between 20 to 50 gigabytes. A good rule for thumb. No more than 20 shards per gigabyte for JVM heap. If an index already has too many shards, use the shrink API to bring that number down and turn on ILM rollover at 50 gigabytes. So new indexes split automatically. No manual babysitting required. And if you get asked about these in an interview, more shard does not equal more speeds. Right size your shard, don't multiply them. Mistake number two. Mistake number two, dynamic mapping in production. This happens when you send data to Elasticsearch without telling it what type of each field is. So Elasticsearch guesses. It sounds convenient until a typo like created instead of created creates a brand new field. Over months, hundreds of these type of fields pile up until the cluster hits its field limit and crashes overnight. The real danger: you can't change a field type after the fact. You have to rebuild the entire index from scratch. It's like librarian creating the whole new shelf label every time someone misplaces a book title instead of just using the shelf that already exists. Now, how to resolve it? Always define a field ahead of time. That's called explicit mapping. Before real data starts following in, set dynamic strict so Elasticsearch rejects fields it doesn't recognize. Instead of silently creating them, and always test new data sources in the staging environment first. Never leave. Remember the one mapping mistake and the hardest to undo. Define a typo before your index, not after. Mistake number three, and this is the one surprise a lot of people. Giving Elasticsearch too much memory. It sounds backwards, but past a certain point, more heap makes things worse. One team gave 128 gigabytes server, 64 gigabytes of heap to be safe, and query time actually goes worse because of multi-seconds garbage collection process. Here's the technical reason. About roughly 31 gigabyte Java loses and memory saving tricks called compressed pointers. And every object in the memory suddenly takes up to 40 to 45% more spaces. Think of heap memory like your desk. A bigger desk sound great, but past a certain size you can't reach across it. and clearing it of takes longer time every time. How to fix it? Set up your heap to 55% to total server RAM and never go above the 31 gigabytes. Full stop. Keep your minimum and maximum heap setting identically. Leave the rest of RAM for the operating system's file cache, while Elasticsearch actually depends on to stay fast and no one bigger servers. Favors several smaller nodes over one giant one. Bigger heap isn't always better. Stay at under 31 gigabytes always. Mistake number 4. Wildcard and unbounded queries. This is running such like leading a wildcard asterisk error or deep pagination past 10,000 results or indexes with hundreds of millions of documents. One of the 100 million document index, a single wildcard query structured CPU across every shard and blocked every other search from one query. One user. A leading wildcard forces Elasticsearch to scan every single time it can't use its normal shortcuts. It's like rendering every page for every book in a library to find one word instead of just using the index at the back of the books. Use search after instead of deep from and size pagination. Replace wildcard queries and prefix or much phrase queries whenever you can. Turn on doc values for any field you have aggregation on, and use filters which get cached instead of full queries to extract exact matches. Here's the takeaway. If a query can't use the index, it doesn't scale. Rewrite it before it reaches production. Mistake number 5. Mistake number 5, no snapshot strategy. Running production with no automated backup at all or stopping backup on the very same servers as the live data. In the audit, 18% of the cluster were already using over 70% of disk spaces. One traffic spike away from the full disk that corrupt writes with no working backups to fall back on Elasticsearch. Elasticsearch has no undo button and no recycle bin. It's like saving your progress in a video game before a hard level. Skip the save and over one crash wipes out everything since your last checkpoint. Setup for SLM, Snapshot Lifecycle Management. For automated daily backups, store those snapshots somewhere like Amazon S3, GCS, or Azure Blob. Never on the same cluster. Keep the 7 days of backup history. And this part gets skipped constantly. Actually, test a restore every quarter. A snapshot you have never restored is not a real backup. Mistake number 6, mixing node rules. Letting every server handle every job at once, master, data, ingest, and coordinating, with no separation as the cluster grows. One 3 node cluster ran fine at low traffic, but under real load and the master role got starved for resources, and the whole thing stuffed full outages that look exactly like a hardware failure. It wasn't. It like asking a restaurant manager to also cook every dishes and wash every dish. At the point nobody actually managing the restaurant. How to fix it? As a cluster grow, decide at least 3 nodes purely to the master role. No data, no duties, no ingest duties, no data. Let other nodes specialize as data ingest and coordinating only nodes, which can route queries and take load off the data nodes. Review your node's role anytime your hardware or traffic increases. Small cluster can get away with sharing rules. Growing cluster can't separate them earlier. Mistake number 7. Mistake number 7, ignoring index lifecycle management or ILM. Letting index grow forever on expensive, fast storage with no plan to move, shrink or delete anything. One logging cluster keeps every log on the host SSD nodes, regardless of age, even though 95% of the search only ever touched the last 7 days. That alone can waste 60 to 80% of your infrastructure budget. It's like keeping every grocery receipt from the last 10 years in your kitchen drawer instead of an archive box in the attic. How to fix it? Set up ILM policy with real data tiers. How hot for new, fast access data, warm for older and cheaper, cold for rarely used and compressed, and delete for automatic cleanup. Roll indexes over automatically at 50 gigabytes for 30 days. Whichever comes first and match the each tier's hardware to how often that data actually gets read. Data gets colder as it ages. Your storage plan should follow the same curve. Mistake number 8. Mistake number 8, excessive replica counts. Setting 3 to 5 replicas on every index just to be safe, whether not or not in actually needs it. One team set 5 replica everywhere for extra safety, and their write-heavy indexes ended up to causing constant heap pressure that slowed down completely unrelated search across the whole cluster. Every replica is a full copy that has to be updated in sync on every single line. It likes photocopying every page you write 5 times over, even pages nobody will ever read. That's not free insurance. It's cost real time and resource every time. How to fix it? For most production workloads, one replica is genuinely enough, and extra replicas only for will read heavy indexes that doesn't changes often, and temporarily set replicas to zero during the large bulk import jobs. Then restore them afterwards. Audit your replica counts regularly with the cat index API. More replica means more safety net for reads, but a bigger tax on every write. Mistake number 9. And this is the one of the highest real world stakes. No security configuration. Running Elasticsearch with default settings, no passwords, no encryptions, reachable straight from the public internet. One company left 1.9 one company left port 9200 wide open with no login required. Their entire customer database was found for sale online and regulatory founds followed. Attackers are actively scan the internet for exposed cluster like this. It's not theoretical, it's leaving your front door wide open with a sign that says vulnerably valuables are inside. How to fix it? Turn on XPack security. It's been free since Elasticsearch 6.8. So there's no excuses. Enable TLS so traffic is encrypted both between nodes and the client. Set up authentication and role-based access control for every user and service, and keep the cluster off the public internet entirely. Bind to internal IPs and firewall ports 9200. A default configuration cluster is unlocked cluster. Security here is not optional. Mistake number 10. And mistakes. No monitoring, running production with no dashboards, no alerts, no visibility into the cluster health at all. One cluster disk uses script up to 4 months with nobody watching. It's hit 100% overnight, and the entire cluster went red only until an emergency cleanup. Warning signs like rising heap and use and shrinks disk space build up quietly for weeks. Without monitoring it, the first sign of trouble is usually a total outage. It's like drive a car with no fuel gauge and no warning lights. You only find out something wrong when the car actually stops. How to fix it? Turn on elastic stake monitoring on an equivalent external tool. Set alerts for heap usage, garbage collection, pause, disk space, and node availability. Review your dashboard on a regular schedule, not just after something breaks. And treat monitoring as a part of the initial cluster setup, not an optional add-on. If you can see it, you can fix it before it breaks. Monitor from day one. Here's the full list in one place. Use this as checklist for your own cluster or as a last minute refresher before an interview. 10 mistakes, 10 fixes, and the exact keywords to remember each one of them. Sharding size, mapping, explosion, compressed ops, leading wildcard SLM, split brain ILM tiers, right amplification, XPack and RBAC, and observability. If you only remember one slides from this deck, make it this one. Every mistake is in the deck is flexible, but diagnosis is correctly. And fixing it without downtime takes real hundreds on elastic experience. That's exactly what our team does. A full cluster audit and health report across all 10 failures pattern performance optimization that typically delivers 3 to 10 times faster queries with no new hardware. Production handling for security and backups, and ongoing advisory whenever you need it. The best time to audit your cluster is before it falls. The second best time is right now. Thank you everyone. If you have related query, please put them in the comment box.